Okay, anyway, I was just showing you when we did a directory on a tuple and a directory on a list, that'll show us the namespace. And that has all the methods and properties of these objects. And I was just showing you, trying to show you that the list object, the one on the right, is a lot more complicated. And the difference is most of these methods that show up at the bottom. And these methods on a list are things you can use to change a list. But if your object isn't changeable, you don't need all those. So as a result, your object is a lot more nimble, and it's a lot lighter weight. It takes up fewer resources generally just to exist. And hidden from that is the fact that you can make a really tiny list and you can extend it. You can make it longer. So the interpreter, the thing under the hood that's trying to figure out what you're typing and how to bring it into computerese, knows that the list can change. It anticipates that if you make a small list, you'll eventually make it bigger. So it not only goes and gets the memory it needs for what you asked for, it looks down the road a bit and it gets even more. Okay, so a list object takes up a lot more space than you think it does, or it takes up more space than the objects you put in it would imply. A tuple doesn't have that problem. So it's thrifty from a lot of perspectives. And so the string takes advantage of that. It tries to be lightweight, and that makes it really versatile, because you can't accidentally change it. Once you've made it, you've made it. It also, because it's immutable, it makes it a good candidate to use as the key in a dictionary. Like if you want to go look up, like if we make a statement like A equals 1, 2, 3, what we're doing is we're inserting a name called A. We use that as a key in a dictionary. And every time we ask to use A, anywhere else in the program, well, Python will go into its lookup table. It'll look for A, and it'll find what value is associated with it. All right, now it wouldn't make any sense to be able to do that if A were changeable, would it? It'd be sort of like having an ISBN number on a book that's changeable, or somebody's passport number being changeable. That kind of wrecks the whole idea. So that's another reason that strings are immutable. You have to remember that, though, because there's all kinds of things you can do to make a string. So we might say Pat has a husky. So, and then we can ask it to report itself, and it'll tell us that. Okay. If we wanted to do an operation on that and say string got capitalized, like so, we would get a capitalized version of that. Or if we wanted to get an uppercase version of it, we'd get an uppercase version of the same string. All right, but even as we do so, the string is the same because we can't change it. All right, so what any of the operations we're going to be looking at over the next couple of hours, whenever they change it, like so, what they're doing is creating a brand new object. And we can prove that. We can give this a name. We can call this up, say. And then we can ask for the question, and 2 equal signs here because we're asking a question, whether this thing up lives in the same memory location as string. And of course, we'll find that it doesn't because they are different. All right, and that's a different behavior. If we say something like 1 is equal to 1, and we say ichi is equal to 1, and we say uno is equal to 1, we can do all that. And what we have here is a bunch of names that'll show up as keys in Python's dictionary. Each of them will have the same value. But Python is pretty clever because it doesn't need an extra copy of all these. So we can ask if all of these guys live in the same memory slot, and we'll find that they do. Okay, so that's important to keep in mind. You're creating a new object every time you do an operation on it. That operation is going to live in a different place in memory. And that behavior is going to be very different than any other mutable or changeable objects that you may run into in Python. Okay, so let's get your slide up, one you were able to admire for so long. Okay. So we talked a little bit about immutability, and the next thing we'll show you is how you can search a string, a few ways to change a string, and a few ways to edit it. And I will try not to belabor too much, but when we say changing a string or editing it, because they're immutable, we're not really changing that string. What we're probably going to do is make a copy of that string, which we can do in a new object, but we won't actually be changing or editing them. Okay, so here's another little example. So we got a variable string that does not involve my dog, which is kind of a little bit of a letdown, but that's okay. But it is Clarusway, so that's cool. So we've got some kind of a string. We've assigned it to a name. And then we've asked it to use a method lower, okay, to give us some other permutation of that string. Okay, so when we printed this out, what we did is we created a new object using the lower method here. Okay, now we didn't assign a name to it. We didn't have to. But we took the return from executing the lower method on that string, and immediately we fed it in as an argument to print. Now, print doesn't care whether or not the thing has a name. It doesn't even care what it prints, really. It'll do anything we want to. But it takes that new object intact and then prints it out for us. And just to prove immutability, we're printing out the original, and it's just like it was. We can assign a name to it, the new object, just like we did for the thing with the husky. Okay, and we can print that out because not only have we created a new object over here, because we've assigned it to a name, it's going to remain accessible to us. We did the same thing up here, right? But Python under the hood has something called garbage collection. You may have heard of that from other languages. But the idea is that when you're playing around with a computer program, you're making all kinds of objects. Some of them you want to keep around. And if you want to keep them around for a while, you'll give them a name. If you want to keep them around after your program has stopped running, you might save them to a hard drive or ship them off over the internet or something. But the idea is that as soon as you're done with an object, it makes sense to get rid of it. Otherwise, it just takes up resources. Now, with some languages, you have to do that deliberately. You have to make constructors, say, and the constructor is how your language is going to build an object when you decide you ask for one. And you have to also write destructors, which give instructions on what to do with the thing when you're no longer needing it. And oftentimes you have to tell your programming language when to apply the destructor because it doesn't really know. Now with Python, you can apply a destructor. You can use the del, delete keyword, and you can just trash an object. But it's very, very rare that you actually need to do that because under the hood, Python's got a little daemon, they call it, a program that runs in background, and it looks for objects that don't have names, like this object. We created it for sure, right? We can see that, and we printed it out. But as soon as this operation was done, the garbage collector knew we were done with it because, well, heck, we don't have any way to get to it. It doesn't have a name. Okay, so that's how that's working under the hood. Okay, so just have a look at this one and see if you can figure out in your own head what this is going to make. And you can type it into your keyboard if you want, if you have a keyboard. And if you thought you'd get a lowercase version of it, I don't know. Are you gonna? Because here we just created a new object. We didn't assign it a name, and we asked it to print out the original. Yep. So I don't necessarily agree with this label. We couldn't change the string. I mean, that's literally true. But we did make an object that reflects a change in a new object, but because we didn't give it a name, it's gone. It's just in the ether. It got collected by the garbage collector long ago. Okay, questions on any of that? All righty. So we got a whole bunch of ways of searching a string. One is starts with, and the other is ends with. And let me just show you some in my notebook here. And we can probably get rid of these. Okay, so let's get our string back here. Okay, so we've got a method called string.startsWith. Okay, it's a function, and we don't really need any arguments with it. If we want to have a look at what we can do with it, we can look up here and say, we can say str. That's the name of the Python object, str, and we can look at the. We want to say help. Okay, and here's the brief description. Okay, and here's our signature. Okay, and you can tell it what you're looking for in the beginning of the string. Okay, and there's a few more specifications. You can tell it exactly where to look. So, and this is kind of really weird to read. Let's walk through it because it's really good to understand these signatures. So we have the name of the method here. Starts with. Okay, and then if it's got an argument here, that's going to be a required argument. So it's a positional argument. There's no equals sign associated with it. So you pretty much need to give it something. Okay, and this says prefix, and all prefix means in English is what something begins with. Okay, now if you want to, this is optional, you can give it the position that you're going to start looking. And if you want to, you can tell it the last place you want it to look. So in other words, you can specify a substring with the start and the end. So you don't have to really ask it for the beginning of the string. You can say, okay, I want this much of the string, and within this much of the string, tell me if it starts with something. All right, and this bit over here tells you what it's going to return. So you're going to get a true or false value. You're going to get a Boolean evaluation of the proposition that your string started with something. Okay, so let's get rid of that for a minute. So if we've got the string starts with, well, we might say Pat. Okay. Now, with any luck at all, it'll figure out that this string begins with Pat. Okay. What if we ask it, does it just begin with P? It's cool with that. It doesn't care how long the string is that you're looking for in the beginning. Okay. Now let's try something else. Let's try TAP. No, it doesn't begin with TAP. Okay. Let's say, let's ask it to start with, let's see whether it starts with has. Okay, as in Pat has a husky. And we want it to start looking at position 0, which is the default. That's probably going to tell us false because it doesn't. All right. And now if we wanted to ask it about has, and we want it to ask in the string that begins here, which is position 0, 1, 2, 3, 4. So let's ask it if it begins with Pat, if we use a substring starting at 4, and it does. All right, see, you can tell it where to start looking. All right. Now, now this is kind of silly. You wouldn't necessarily want to do it this way. Let's just put a couple of notes in here. So this is going to be like a full string. And this is going to be a short prefix. Okay. And this is going to be a swing and a miss. Okay, and this is going to start at the beginning. And this one is going to be start at position 4. Okay, now this is going to be kind of silly, but we can ask it to start at position 4 and just go 2. Okay, so we can say start at position 4 and give it an endpoint of 6. Okay, and it probably won't have much luck because what we're doing here is we're saying we're asking it to go and look at STG, and we'll do a slice operation from 4 to 6. Okay, and 4 to 6 doesn't quite cut it. But if we
the screen is black.
Screen is black?
Yes.
It's black. All right. Why is the screen black? You mean it's blank, like white, or it's literally the color
I can
black?
see the screen with no problem.
Yeah, even I can see the screen.
Oh, okay.
Okay.
I don't know. Maybe you got to hold your jaw differently. I hope it comes back. It could be a bandwidth problem. I'll share these notes anyway after class. If we wanted to do a little longer string, you see, it's not inclusive of this last element here, so it works just like a slice. So if we wanted to do string to 4 to 7, we'll grab has out of it. So if we come down here and go 3 and go beginning at 4 and going all the way to 6, so positions 4, 5, and 6, with any luck, we'll get it. Cool. All right. So you can start looking at a string just about anywhere. And I'll actually do one more thing here. Starts with. All right. So you can start just about anywhere in your string, and you can look at whatever size of a substring you want, and you can look for anything that you choose. Okay. Questions on that? All right. Now there's another method that works pretty much the same way, really. It's called, come on, ends with. And that you get to with string dot ends with. Like so. If we come back here, we can get a little bit of help on it. We'll see the signature is almost exactly the same. Okay. Instead of prefix, though, it's a suffix, which is just a fancy English word for what a word ends with. All right, and we'll return true if it ends with the specified suffix. Okay, and you can test a substring either with the first position alone that you're going to be looking in, or the first and the last position. And like starts with, you'll get a Boolean return back. Okay, so let's look at our string. Okay, so if we say string ends with, and we ask it for a KY, well, it's probably gonna do okay. Okay. And I just want to put one more thing up here. Okay. So, and we can ask it for any string length. Like so. Okay. If we want to jazz that up a little bit, we could say string dot ends with, and we got to give it the thing we're looking for. And let's make it something else. How about, let's go for has again. All right, now this implicitly looks only at the end. Okay, and that's going to fail miserably, right? Because it doesn't end with has. Okay, but if we ask it to look for the same thing, and we tell it where to start looking, okay, like if we wanted to look at this part of the string only, it will. So this is going to be position 0, 1, 2, 3, 4, 5, 6. So essentially, we could, if we wanted to ask for in the substring 0 to 6, which won't quite cover it, we'll have to go to 7. We can ask it to look for that if we say has, and ask it to begin at 0 and end at 7. All right, and let's just pop another one of these in here and ask it for the slice of the string that's 0 to 7. Okay, and that ends with has, so this specification should result in a true value for us. And it does. Okay, and obviously we don't, since ends with only looks at the end, it's only looking at this bit of it, right? So if we wanted to not start at the beginning, if we wanted to start at position 2, say, and go to position 7, we'd be looking inside of this substring specified by this slice. And this 2 should evaluate as true. All right, see how that works? Clear as mud? Everybody asleep? How can you be asleep if we're talking about my dog? Okay, I get it. It's really late for you guys, much later than it is for me. Okay, so just to review a little bit, if we had a text like Clarusway.com, and we asked it to print whether it ends with .com, what do you think it would do? All right. And if we asked if it starts with HTTP, what do you think it would do? Now, these two are going to work a little bit differently, right? The first one's going to look at the end and the second at the beginning. So I think this will succeed and this will fail. Let's look. Yeah. Okay. So we're just picking off different stuff. Okay, so here we got text is clarusway.com. We've got an ends with OM and it starts with W. What do you think it'll do? I think it's going to say true, true. Probably. Yes. Okay. Okay, and we looked at the syntax. Okay, and it's really horrible notation. You know, I'm glad we took a minute to go through it. And it's all horrible, you know, if you look at the signatures. But there's a method to the madness. They're all horrible in exactly the same way. And it's all coded. And once you crack the code, it'll be really obvious to you and you'll find it beautiful and parsimonious. Until that happens, it'll drive you insane. But it's worth decoding if you're serious about Python, because by far the easiest way to get help is just to type help, and you don't have to go out to Stack Overflow or the official docs and spend a whole bunch of time if you just need a silver bullet answer. Okay, yeah, we talked about this. The ends are not included. So these substrings work just like a slice. So if you just remember that, you won't have a problem. Okay, so if we had this email address, we're gonna ask if it starts with this prefix. And if you only have one argument, that's the starting location. Okay, and here we're going to ask if it ends with a dash. Okay, so we're looking at the end of it, and if we have two arguments, this is the beginning and the end of the substring, the index values it would use in a slice operation. So see if you can just noodle that through a little bit. Okay, I'll give you like 20 or 30 seconds. Okay. So I looked at these slides before you did it. There's instead of like talking you through it, I'll just show you this. I think Joshua, I think he made this. This is very clever. So anyway, this maps the index values of our string, zero based, of course, And our index point of 9 is right over this ampersand. So it looks like this will succeed. Okay. Now the ends with, we're looking for a dash. And it says we're going to start at index point 10, which is here. And we're going to end at index point 32 here. But remember, we're not going to be inclusive of the endpoint. So we're really going to look to here. And this is the only one that matters. The start point doesn't matter here, but you have to put it if you put an endpoint. So yeah, this looks like it'll succeed as well. Does anybody disagree with that? Okay. And yay, we got it. Okay. So how about this one? Does this end with a CO, a .co? Does it start with a W? W dot, I should say.
False, true. Okay, false, false.
All right, it doesn't, because these are trying to be exact. So we have, it starts with WW, not W dot, and it starts with .com with an M. So these both failed. Okay. So we're gonna look now at some methods for changing a string, or at least making an object that represents a changed string. And the general syntax is all the same. We got string.method and then some arguments, and the arguments, of course, will vary by the method. So it works just like anything else in Python. Okay. And here is a list of some of the most common stuff you can do. Okay, there's a replace operation. Okay, so you can just change out something called old here, and you can replace it with something called new. And we'll play around with all these in just a minute. And you can tell it how many times to do that. And if you don't tell it anything, it'll just replace all occurrences of the thing it finds with whatever new value you wanted. And there's a few things you can do to the casing. Okay, there's a swap case, and that just flips the case from upper to lower. The capitalize, it just capitalizes the first letter. Not that interesting, really. If you want all upper or all lower, you can do that. And these conversions are particularly useful if you're comparing a couple of strings. And I'll give you some use cases for that. There's a title case, and title makes, like this up here is title case, where the first letters are capitalized. Now, normally, in English anyway, if you have a really small word like a or an or the, you don't capitalize it, even in the title of a book. But Python's title case is actually terrible. It goes ahead and does that. It's got all kinds of problems. There's other and better ways to make a good title case. I'll point out the issues with the out of the box one. Okay, so let's go over some real examples. Well, we've only got 4 minutes before break, but let's give it a start. Okay. Well, this is just so I don't forget. String casing operations. Okay, so let's say you made a web page, and you've graduated from Clarusway, and you're now a world famous Python consultant, and your web page says something like, "Do you agree to my $2,000 a day rate. And yeah, give them a blank to fill in. Okay, and you've got to process that in your website, in the back end of it. Of course, you want them to say yes, right? But what are they going to really say? They might say why. They might say why, like that. They might say yes. They might say yes. You don't really know. And you don't want to have a whole lot of logic in here to try to determine it. So let's say the user input was yes. And your test under the hood is yes. And then you're going to ask did what the user give me, is that the same as the test? And it's not. So your website might snarl at your user or kick them off or something like that, and you would lose $2,000 a day. Now, you really don't want to do that. So what you really want to be able to do is use these string methods. And this is one of the use cases. So when your test might say something like input.lower, and you'll ask if that's the same as your test.lower. Okay. Now that makes it a lot more robust, doesn't it? So now we'll get the yes answer we're after, and we'll simply ask him for his charge card. All right. See, Python's made you guys money already. All right, guys, we're back. So far we've talked about string immutability. And we've talked about a couple ways to search strings, starting with and ends with, and how we can be fairly granular about that. Does anybody have questions about what we covered so far?
Can I ask a question, please?
Please.
Like when you show this notebook, right? You just use some keyboard shortcut to pop up another window for the help. I think the last time you had said it was Control B, but I am trying it. It's not happening.
Okay, that's a really good question. Yeah, I'll just show you a couple here. So we've got this this cell highlighted now. If we just say B, we get a new cell under here. If we say Control B, we get a little pop-up here. Does that not work for you?
Like B for bull, right?
B for boy.
Yeah, it's not happening. I don't know why.
Okay, it might be, if you go to your home page, I have a tab that says NB extensions. Okay, and that's because I installed notebook extensions onto my Jupyter installation, which I got through Anaconda.
Okay, I don't
Okay,
have
and-
extensions.
Okay. And then that might be one of the issues. So like my ability to split the cells is tied to this, and the scratch pad, that's what we're looking at. So if you install notebook extensions, you'll get the ability to have a scratch pad and all these other things if you want them.
And how do I get the notebook extensions?
Let's see, we got a cheat sheet here. Let me pull it up here. Let's see. I got cheat sheets for everything here. Jupyter, extensions. Okay, I'll just paste my notes into the Slack channel, and you can have access to them. Let's see, and I'm going to put this. Hang on just a second. Slack is being very bulky right now. Tech community. Okay. A second, guys. I'm so sorry. Here we go. Class chat. I'll put it in class chat right now. Okay, there you go. It could take a while to install it, and the notebook extensions are just a little bit flaky. They might not work right away, and you might have to fiddle around with them, but you'll get them going eventually. That was a good
Sure,
question.
I'll try this. Thank you so much.
Anybody else have questions? Okay. So if you have this extension, if you hit Control B again, you can get rid of this scratch pad thing. Okay, so here's a use case for string casing. You've got a user input of some kind, maybe from your website, and you don't have a drop down or anything, so people can type in whatever they want. So you can use these string methods. So you're looking for somebody to say yes to your proposal for $2,000 a day for Python programming. But if they type in Y with a capital, you don't want to reject that. So one thing you can do, you don't have to assign a new name to any of these objects, but you can ask it for a lowercase version of what the user typed in, and you can compare it with a lowercase version of what you're looking for. And that'll keep them denominated the same. You might want to even say just like input.lower. And now you can chain these operations together, because each one of these returns a string object, right? It's a new object, but they'll feed into each other, right? So here we'll ask for a lowercase version of the user input, and that's just a string. And even though we're not going to give it a name and it's not going to stick around for a while, it's still an object and we can work with it. So we can use a string method on it, like so. Or we might want to ask it if it starts with not necessarily Y, but we might want to say the test. We might ask it for the first member of test, which is going to be lowercase y. And we might, if we wanted to be really sure, we could ask it for a lowercase version of the first element of test. Now this all looks like gobbledygook, I know, but here we just have a lowercase version of the input. We're asking what it starts with, and all we're asking it for is all we're testing for is it a lowercase version of the first letter of the test we proposed. If we can do the check algorithmically like this, then if anytime we wanted to change our test, right, or we wanted to test against different sorts of things the user might put in, it would be pretty easy to do that. Okay. So let's have a closer look at upper, lower, title, and swap. Oh, and also capitalize. And these all work exactly the same way. And we want to make this a markdown cell, which we can do up here. That way it'll look a little bit nicer and it'll show up in the table of contents, which you can also get if you put in the notebook extensions. Okay, so let's look at our string again. Okay, so if we wanted to say string.upper, it's just going to return an uppercase version. And if we want to look at the signature of this, it's not going to be interesting, right? At all. All it does is returns a copy of the string converted. And that's all any of these methods we're going to look at right now do. So they don't have switches or options or anything crazy like that. So they're actually pretty boring. They just work. Okay, so here you get uppercase versions. Now, if we had a string that had weird characters and numbers and all kinds of stuff like that, it's still going to be chill with that, right? It's still a string. But it'll just ignore what it can't deal with. Okay, so all that'll be good. So you can apply this upper against any kind of a string. Okay, let's call this one up, just so we have a target. So we can say up.lower, and it'll do exactly what you think it'll do. It'll return a copy all in lowercase. Okay. If we wanted to look at capitalize, all it'll do is just change the first character. All right, and we don't really need this. I mean, we could say something like up and take the first element of it and call that upper, like so, and then concatenate it with the rest of it from one to the end, dot lower. So we can roll our own versions of capitalize or anything else just with upper and lower. And that becomes a little bit interesting, because if you take title, so let's look at our string again, then say string.title, you'd expect it would look like something like a book title, and it doesn't. It goes and capitalizes A. In fact, it does that with every word. So you can say a pencil and an apple, and it'll capitalize A and an an. I know those don't come across very well over a computer speaker, but you'll see what I mean. Okay, it capitalizes everything. And it does something really weird. If we wanted to say something like Pat's Husky chews on the Corgi's ball and do a title case of that, not only will it go and capitalize the tiny letters, but look what it does to the apostrophe S, right? So for some reason, it thinks it should capitalize this S and this S. So anyway, title is pretty awful, and you sure don't want to trust it. For some of my longer classes, I do a lot more exercises, and the exercise is to write a better title case, because it's got more problems besides these. Okay, and what else? We have swap case. So here's our string again. That's not even going to be very interesting. Let's do this. Let's take this up here again. And we'll do a swap case on it. Right? Because as you saw, this returns a string. And we can use any other string method on that string. And what this is going to do is every time it hit a lowercase value, it turns it into an uppercase. And every time it hit an uppercase, it turns it into a lowercase. Now, for the life of me, I don't know why you would ever need that or want that. But if you do, it's there for you. Okay. Questions on that? All right. Let's see. Replace is pretty cool. This lets you replace something with something else. Okay, and what you do is you give it the existing thing, any kind of a string. So you can replace Husky, and then you can tell it to replace it with something else. Let's call it a Turkish wolf, which is what it's called in Turkey. It's called a wolf. Okay, so this is going to return a string with this particular string replaced with this particular string. All right, and you can string this together with more string operations, and we might want to replace, and we might want to switch my name out with Lord of the Wolves. Oop, didn't mean to do that. Okay, so we can chain these together, and we can switch out as many elements in our string as we want to. All right. You can also do smaller strings. So let's get our string back. And you can say string.replace. And you can replace every instance of a lowercase a with something like uppercase a's. And it'll go through, and every time it finds an a, kind of sounds like what a sheep would say, right? Pat has a husky. So anyway, it'll go ahead and replace every instance of this a that it found with this string. Okay. We could, if we wanted, tell it only to do that a couple times. So let's say string.replace. Same thing as before, but we can give it another argument. And we can maybe ask it only to do it twice. It'll respect that. All right. Let's look at the signature.
Can I ask you a question here?
Yeah, absolutely.
Could we do, instead of like replace the A to upper A 2 times, instead of 2 times, could we do starting from this and ends there? Change the A to upper A, but not the first one, on the second one and the third one. Don't do the fifth one, for example.
Yeah, we can't do that with replace, but we could do it by chopping it up a little bit.
With slice and replace together, you mean?
Yeah, so we could say our string, and let's go from the first element. We don't even have to tell it the first element. And this will be 0, 1, 2, 3, 4, want to start here, maybe at
Mhm.
5. So if we want to say from here to 5, we'll just leave that alone. And then we'll say from 5 to the end, right? So this slice operation is going to return a string, right? Let's actually put in another thing here. So we can say string from the beginning, 5 elements. So you can see that returns a string. So we're going to return that string intact. Then we're going to take everything that follows it, which is also going to be a string. And here we'll replace A with A, like so. And the plus sign is concatenation, right? So we're just going to split it in half, do a separate operation on each half, and cram them back together. Is that what you had in mind?
Yes, something like that.
Yeah.
Perfect. Thank you.
Sure. Sure. Good question. I appreciate it. Okay, so here's a signature of it. So you can see that it requires an argument for old, right? The existing thing. It requires an argument for new. That's what it's going to be replaced with. And you can tell it how many times. But as was just pointed out, we can't tell it where to start. Okay. Questions on that? Okay, I'm going to see if this is covered. No, it's not. There's one more thing I want to show you, and that's a method called find. Now, find is kind of interesting because it'll find a substring in a string. All right. So if we wanted it to find stg.find, and we could ask it to find A, it's going to come up with the index value of the first occurrence of A. So let's just do our string here. Okay. So it's index value 1. So the P here, that's index value 0. So it tells us that A is at 1. Okay. If we wanted it to not begin at the beginning, we basically told it to do A0. Excuse me. So we've told it to start at 0, which is the default. If we wanted it to start somewhere else, we could just say stg.find A, and we could say, well, don't start there. Let's start somewhere else. You know, maybe wherever this S is. And geez, I don't even know where S is. So let's ask. So let's say string.find S. That'll tell us where the S is. Oops, sorry. stg.find. Okay, so S is at position 6. So if we wanted to start here and we wanted to find the next occurrence of the lowercase a, well, heck, we don't even have to count like 0, 1, 2. That kind of is tedious. So we could just ask it to start wherever the first S is. And that will give us the right index point. Okay, so S was at index point 6, and the next A is 2 past that. So that checks out. Okay. And just as we did with just as we did earlier, we can give it both a beginning and an endpoint. So if we wanted to say string.find tg.find A, then we could tell it the start and the end. So we could ask it for beginning at position 6 and ending at position 10. It'll be happy with that. Okay. So this one has a fair amount of flexibility. Now you see it returns the index point. So if we wanted to use this in a slice operation, we could just put it in between braces, like so. And with any luck, this will return what we're looking for, and it does. So the message here, beyond just learning mechanically how these things work, is the fact that you can combine string operations in a lot of ways, right? You can combine them to get slices. You can feed them as arguments to other things. And way up here at the beginning, we were able to do something like this, where we just kept creating string objects, like here, the first one, and then we use the method of the string object, of the new object, like so, creating another new object, and then we used the method of the other new object to come up with our final product. Okay. So there's another use case I'll just throw out here. I had this one project. It was it was really fun. I worked with this marketing research company, and we did employee satisfaction surveys. And we had a lot of open-ended questions, right? So the question is, what do you think of your boss? And they could answer any way they wanted. Well, not everybody liked their boss. So we, before we could actually turn this stuff over to the company that paid us, we had to go through it and screen out certain words. So our answer might have been something like, my boss is a dog, and he should be tarred and feathered. And I know nobody really said that, but what we did is we made a list of stuff, and that might include the word dog, and it might include the word tarred, and it might include the word feathered. All right. So what we did is we went through, and we had a lot of fun making this list. I mean, this is safe for work, what I'm showing you right now, but what we did was not safe for work. So we sat around after work in a bar, drinking on our boss's credit card, and we came up with a list of words that we would want to screen for. So we did something like for word in list, okay, and we said answer is equal to answer dot replace sorry, we started off with a clean list like this. This is a little bit more than we've covered before, but we just made an empty list. Then we went through every word, okay, and we appended that word. And this is how you add something to a list. One way to add something to a list. We appended the word how do we do? Oh man, let's see. So let's see. For now, it got a little more complicated than this, which I'm not going to go through. Sorry. Well, what we did anyway is we. Oh no, we can do this. So basically, we said answer dot replace. And every time we found a magic word, we replaced it with something like this. Okay. And we updated the answer every time. So what we ended up with is something that was cleaned up, and the bosses didn't get too upset. But everybody kind of got their say in, and everybody got the idea of just what it was. So anyway, this is a use case. If you have a list of words that you'd rather not see for whatever reason, you can just go through and very systematically change those words to something that that nobody will get in trouble for. All right. Okay. So any questions? Okay. So here's another little exercise. So here, I live and work in Virginia. All right. Try to think in your head what it's going to do if we apply upper, lower, and swap case to it. And finally, what we'll end up with. And I'll give you, I'll shut up for 20 or 30 seconds and let you think it through. Okay. Here are the results. Uppercase, just put everything in capital letters. Lower, put everything in lowercase letters. Swap case, just did something weird to it. But our original was unchanged. Everybody get that? Okay. And we saw that we could chain methods together. And we could do that because every time we apply one of these methods to a string, what we get back is a string. Okay. Now that doesn't work for all the methods, but all the ones that will do a thing like a swap case or an upper and a lower will return a string. Okay. So here's a few more examples, again, with I live and work in Virginia. Okay, here we're applying title. We're going to do some stuff to it and just think that through it. And again, I'll give you half a minute or so to think it through and see if you can come up with all the right answers. Okay. Now, did everybody catch that we have some reassignment going on? We've assigned the results of a string operation here to a new object. That lets us hang on to those changes, doesn't it? And here we did the same thing. We assigned the results of this replace operation to a new variable. So we should preserve changes both in the title sentence and the changed sentence. Okay, let's see what we got. Oh, there we go. Did everybody get that? Okay. Okay, so how are you going to change the first letter of every one of these words to uppercase? It's one of the methods we covered. It's the one I hate most.
Capitalize.
Say again?
Capitalize.
You might try it. Capitalize the first letter right here.
Okay, I was thinking about doing title and then doing swap case after.
Okay. I don't know you have to do swap case. Let's
What about
let's
replace?
try it.
Only title, isn't it?
I think only title will do it. But let's give it a try real quick. So we're going to say we'll just call it S tree, and the better Husky, the better the society. Okay, about what it said, right? So let's see, if we say st.capitalize, what do we get? Yeah, see, no, capitalize the first letter here. Somebody else said title. That might have better luck. Yeah, here we go. Yeah, so the answer is title. But you know, guys, I was recently asked to teach a C++ class, and I'm not that good at C++. And I've been playing with it, and yeah, just going back and forth between Python and C++ just makes me so appreciate Python, because in Python you can just try stuff out like we just did, right? Really fast and really easy, you know. And C++ to make a print statement, you know, it takes like 50 characters because they don't have a print statement. So if you ever have a question like this, just try it. You can't break anything, right? And if somehow you hose up Python, you can get it reinstalled, fresh copy, newer version maybe, in about 5 minutes. So by all means, experiment. Okay, and here we go. So let's see. We've kind of looked at these already. Swap case is gonna swap the cases, right? And we have a reassignment. We have a capitalized here. We just looked at that. We don't have a reassignment here, but we can still look at it because we're printing it out. All right. Swap case is going to be a permanent. Well, we'll have permanent access to the change we made because we've assigned it to a new object, or a new name rather. Created a new object on the right, used the assignment operator, and gave it a new name. So that'll be around at least until our script stops running. This is just made, and it'll go in the vapor and disappear. But in its brief millionth of a second of existence, it's going to serve as an argument to print. So it'll print out. Okay. So in the text below, Somebody had way too much fun in Sodom and Gomorrah. So why don't you take a minute and play around with this and see if you can print out an upgraded version of this thing. And don't be afraid to ask for help on the string object str.replace if you're wondering. So let's go ahead and do that, and I'll be quiet for a couple of minutes while you do. All right, so I would be tempted here, just you know, in the spirit of experimentation, made something called S, and it's going to be SODOME and GOMORE. I would have a look at that. And we're supposed to use s.replace. So I'll just look up the help. I'm going to look for string.replace. Get a quick refresher. And I see from the signature here that we give it the old value. Let's see, which is going to be the 0. Give it the new value, which is going to be an O. And it's going to return a copy with all the occurrences of old replaced by new. That looks right. We don't need to limit the count here. Okay, so I think if I just say something like s.replace, and I give it the old thing, which is a 0, and I give it the new thing, which is the lowercase o, I'm thinking that might do the trick. Well, let's see. Yep. Okay, it took me about 2 minutes, including reading the documentation. So, you know, just experimenting, playing around with it proved right here to be a decent workflow.
Can I ask a question, please?
Absolutely.
In the help, I see, like in the help string, the replace, what's the self in that mean?
Let's see. It's a bit of a longish story, but in brief, if you have class dog, and you have a class method, or have some method, it's a function, and you'll always have self at the beginning of it. So if you make a specific dog like Quinn, oh, here we go. We need a def in here. Okay, so we made Quinn, and Quinn is a dog. Okay, and we can also make Sarah, who's also a dog. Well, Sarah and Quinn are both dogs, right? They both have in common everything that this dog class has. And this dog class will probably have a dog name as one of the attributes. So if it did, we could ask for Quinn.name and Sarah.name, and they would have different names. And what the self here means is this, everybody gets their own version of their class. So Quinn has his own version of the class, including dog name, and so does Sarah. So self is a namespace to take care of the fact that everybody's got a different name and a different weight and a different color, but all those variables are the same. And that keeps Python from getting confused about the fact that these different elements, these different instances of the class dog are really different four-legged animals. That's a great question. And it
So
takes us up.
basically, all the methods would have a self in it.
Yeah, all methods that belong to a class. Well, most methods that belong to a class are going to have self as the first argument.
Oh, okay. Thank you so much.
Sure. Okay, it's time for a break, and we ran a little bit late, so we'll start a little bit late. So let's start at 2 or 3 minutes after the hour. Enjoy, and I'll see you then. Hey, I want to clarify something. The last question we had was, what does self mean if you see it in documentation? And we saw it in this documentation here where we had help on a method and we got the signature of the method. Now, the answer I gave is technically correct. Self is a namespace that allows everybody to have a property called name, and they're all different, or a color, and they're all different, which is probably a little complicated. What I should have said, even though what I told you is correct, is if you see documentation like this with self in it, just ignore the self. Because truth be known, this documentation was probably automatically generated, right? A human didn't do it. And all help really does is reads a documentation string. A documentation string is just a line. Like that, okay? And it's just a string. It's usually a multi-line string, but the developer put it in there. And it's kind of a developer to developer thing. And if you automatically generate documentation, what you might do is you might read the signature of the method. So we read this because there isn't documentation for that method. Okay, or there's a little bit. Okay, so it makes it more confusing than it has to be. So to summarize, if you're looking at documentation for a method and you see the word self, ignore it, because it's the arguments after that that you're expected to provide, or you have an opportunity to provide. Okay, so moving on. Does anybody have questions on what we've covered so far? We talked about upper, lower, title, swap case, capital. We talked about how to replace, played around with some use cases. No? Okay, we'll play with a few more things here in our last bit of time together. And here we'll look at strip. Now, what you think? And there's a left strip and a right strip. And these are all things you can do with strings. And I'll show you the basic usage here. So let's say we've got a string. Let's make a new string, and let's pretend this is we captured this by saying input. All right, so we could have said something like dog name is input. What's your dog's name? And we might provide something like a prompt here. And you'll recall that that if you want to have the user type something in, you can do that. If we execute that, here it's coming with a box, and we're invited to type something in. Now, if you ever have to do anything with a user, you're going to come to the conclusion that anybody that uses your program is a moron, right? And especially if you have something like facing the internet, it's a very democratic process, and anybody can type anything into it, like SQL injection code. But they might leave a bunch of spaces and say something like Quinn, and they might leave some spaces after it, right? You have to anticipate that. I mean, it's just part of the world. So if we wanted to ask what we got out of here, and we've captured in the name dog, we see that we've captured all the spaces. Now, if we want to put Quinn into a database or otherwise immortalize him or do anything else with them, we sure don't want those spaces. So one operation you always want to do if you're capturing input like this is you want to do a strip operation on it at minimum. What that'll do is it'll get rid of any trailing and leading spaces. All right, see, we got a nice succinct string, and it automatically did that. So strip, if you just leave it alone and you don't give it any arguments, will take off anything that smells like a white space, and that could be just a real white space, or it could be a tab character, or it could be a new line character. Pretty much anything that you think of as just taking up space without adding content. There's a couple different flavors of it. If you just wanted to get rid of the leading spaces, you could say dog.left strip, like so. Am I unmuted? Yeah. And you'll get just the left trimmed off. You'll have all the stuff on the right. And the opposite of that is just getting rid of the stuff on the right and leaving the stuff on the left. Okay. You've got a few more options with this method than you do with some of the others. You can tell it what to take off. In fact, let's look at the signature on this. So you can give it an argument here, right? We're going to forget about the self, and you can tell it that instead of ripping out the white spaces, you can tell it what to rip out. Okay, so if we had let's make a new string. I hate to get rid of Quinn like that, but let's make a string that says XXX. We can put Quinn back in. How's that? And then say YYY, like so. And let's say we knew that the X's and Y's were garbage input. Now, one way we could get rid of them would be to look for them and to find out where they were, and maybe iterate through and find out when the last one is. Or maybe we might want to eyeball it and just say we're going to take 4 off. And use it.
Non, c'est juste que je suis arrivé tard aujourd'hui.
But we might just use strip. So if we said our string and we said left strip, we could tell it to get rid of the X, and it would take care of that. If we wanted to say get rid of all the X's on the left, well, that's going to return a string, right? Well, we can just go right ahead and say right strip and get rid of the Y over there. And get Quinn back. Okay. So let's say we had a remake our string and do something else to it. Let's say we got a bunch of numbers here, and who knows how they came to be, but we don't want them there. It's a lot of garbage. Well, we can say string dot strip, and we can give it 1, 2, 3, 4. Right? And that works just the same as saying string dot strip 2, 3, 1, 4. We can even give it some other things we don't want in there. Okay, so we can give it basically a string that contains all the stuff that we don't want. And as long as it finds it at the beginning or the end of the string, it'll just go ahead and remove it for us. Okay, so it's actually pretty powerful. And one last thing I would note, as long as we're talking about reading this documentation, you see that there's an argument here that says characters equals none. Okay. Anytime you see part of a signature like this, what that means is that it's possible to provide it as a keyword argument. So it's like name equals value, right? Just like name equals value. It's the same thing. The name CHARS will get assigned to a value if we give it one. So if we say st.strip, well, this invites us, if we want to say CHARS equal, and then whatever we want to give it. Hang on. Okay, well, actually, I just misspoke. The way this looks is it would accept a keyword argument. So this piece of documentation is actually misleading, unless I misspelled it, because it yelled at me, didn't it? It said, we don't take any keyword arguments, thank you. And that's usually what this means. So I might actually drop them a note as a bug fix to take care of that. But it works as a positional argument. Let's get rid of this. But it works as a positional argument. That is, we don't assign a key and a value. Okay, so does anybody have questions about how strip works? Okay.
I think I have a question. Can I?
Yeah, absolutely.
It might not be the place to ask that question, but I wonder, how would we know what characters will be wrong in the answer when the user input? Like, yes, we know queen makes sense, and X and the numbers doesn't make sense, but in the real world, how would we know what makes sense, what doesn't make sense, what they're gonna put, what should I strip? Is there any other way to go around and put the form?
If you solve that problem, you'll make a lot of money. I don't know that you can anticipate every stupid thing every moron on the internet can possibly do.
Basically, actually, maybe I asked the question wrong. So do we put this in code that strip anything else other than that this way, or do we put this code afterwards? Like, we have the inputs and we see the mistakes or the letters it's shouldn't be there, and then we fix with strip.
What you want to do is come up with something automated, right? You don't want a human being looking at a million forms that get filled out that come in.
Right.
So people think about this stuff long and hard, and they know what things they don't want. So they don't want anything that looks like SQL, right? If they're looking for text, they don't want numbers. If they want numbers, they don't want text. If they have a field like for your name, they're going to look to make sure there's at least, you know, a couple of characters in it, but not more than what? A lot of people from India have names that are about, you know, a kilometer long. So you can't really truncate somebody's name.
Mhm.
So what people do is they do artificial intelligence on it, and they do Bayesian filters, like a spam filter, and over time their system learns what garbage input to a field
Oh.
is.
Okay.
They try to figure it out that way, and they don't get it all. I mean, there's been a couple of hack attacks in the news in the last couple of months, and people have done SQL injection. Somebody did that on Donald Trump's new Facebook-like site, and managed to register themselves as every important Republican in the country. But no, there's no
Right.
easy answer to your question that I know of.
Okay. I think artificial intelligence is the answer. Yeah. In time, the website or the program itself will figure out.
Yeah.
Yeah. Got it. Thank you.
Sure. I'm going to get rid of this wrong thing. Okay, so let's have a look. We got our slides have a couple of quiz-like things here. Okay, so here's an example where we've got a big word, and we're going to use a strip operation. Now the right strip, left strip, and strip all work exactly the same way. So we're just gonna, on the right, we're gonna get rid of everything in this string. So a TY in any order. And that's gonna just strip off the T and Y. Okay, what's this one gonna do? Oh, it's the same question. That's not even interesting. Let's go to the next one. Okay. So what would you do to see? Yeah, what would you do to remove the additional letters and make all the words uppercase in one line of code? So why don't I give you a couple minutes, see if you can crack this. You should be able to do it with what you learned today. If you can't, don't worry about it, but give it a shot. Okay. So this is just something you would get typed into your well-crafted web form. And you can see the problems here. We got garbage at the beginning and garbage at the end. So you could use a slice operation and remove the first and last character. But that's kind of cheating since we're talking about string methods now. So you want to use a left strip to get rid of this T. Right, so you should be able to provide a T as an argument to left strip. Whoop. And you want to get rid of Z on the right side. So you should be able to provide a Z to right strip. And you should be able to chain them. You should be able to say text.left strip and then give the string T as an argument. That'll return a string. And then dot right strip on the same line to get rid of the Z. And then say dot upper to turn it into all upper class. So to solve this, you had to do three things right. Okay, so you had to come up with something exactly like this. Now you could do them in a different order. You could move the left, mix up the left and right strip. Or if you did upper first, converted it to upper, you could do the other two in any order, except the arguments would now have to be uppercase. Okay, so this is the obvious way to solve it, but there's at least a couple of more. Okay, so this one asks you to find a way to get rid of the extra E in we, because that's just spelled with one E in English. Let's see if you can figure out how to do that. Okay, you've actually got a few ways to solve this one. The easiest thing to do would be to use replace, because there's only one instance of this. So you could, for the old argument of replace, you could give it this WEE string. And for the new one, you could give it WE. Okay, that's the obvious way to do it. Okay. The other way, another way to do it is with a slicing operation. Okay. And somebody to come up with this solution had to count 0, 1, 2, 3, 4, and figure out where this breakpoint was. But you saw there's another way to do it. We could find the string EE. Let's show it to you again here. So you said, in God we trust. So we got that. So we said S dot find, and you look for EE, that would give you the index number of where the EE is. Right? So if you wanted to start at the beginning or you wanted to start at the end of this, you could do that either way. But you can, the point is you could algorithmically figure out where to slice it to get the right answer. But this totally works. Okay, so you broke it into two pieces, you assigned a name, you did two substrings, and you concatenated them together. And you could have done this in one line of text too, right? You could have just put a plus sign here and a plus sign there, and then printed it, right? So you didn't actually have to create new objects, but this is a fine solution. Okay, and that's the end of the material that they've asked me to present. And I guess you can feel free to leave now if you want, but I do want to show you a couple of other things that I think will be monstrously useful to you. And that is regular expressions. And the first thing I'm going to show you is probably the most important, and that's this most awesome website. It's called Regex101.com. Now, what regular expressions are is a really old what I mean by old is as old as computers themselves. So regular expressions manage strings, and they do the same things with strings that Python does. They're a lot harder to use, and they're only a little bit more efficient. But they give you a lot of flexibility. Now, show you the basics on this. Oh, there it is. So this website is devoted entirely to regular expressions. It's free to use. Now, notice a lot of different languages have regular expressions. Okay, and everybody's got their own dialect. And if you're going to use Python, you want to click on Python. And let's see. What you can do is you can have some kind of string you're working on, like in God we trust, say. And you might want to also put in here something like Quinn is a husky. It doesn't care how much text you have, but what you do is you create an encoded string that is used to parse things out of your text. The easiest thing it does is it's able to find things. So if we wanted to find the string God, it would do that. Okay. So it automatically has a find operation that you don't really have to mess with much. But it's got a lot more. If you wanted to tell it that you want to find something in the beginning of a line, you could do something like that. Okay. Now let's take that away for a second, and you'll see what it did is it automatically tried to find matches. And this up here tells us it found a match. And this over here tells you how this regular expression got processed. Okay, and now there's not much going on here, but as these regular expressions can extend to thousands of characters, and they're just about impossible to read. But this over here will give you an explanation. Okay, this reference down here will show you all the different encodings you can make. Okay. So if, for instance, you wanted to find only matches of things at the beginning of an expression, you could put this caret sign in. Okay. And it might find the word in, but only if it's at the beginning. Okay. If we wanted to find the string S, it'll find a lot of different matches. Okay, and it'll highlight them for us. So it found 3 different matches. And if we look over here, we'll see where it found it. Okay, and this tells us a lot more about it. All right, if we wanted to only find the letter Y, we could do that. If we only wanted to find a Y if it happened at the end, we could put an S here. Now it wouldn't match anymore. Okay. If we wanted to put a Y dot at the end, it would match. Should match. Okay. All right, we need the S, the $sign here. Okay, so it matched at the end. So it's got a lot of different options like that. This capability is embedded in Python in a library called RE. Okay, so you want to import RE like so. And what it'll do is it'll let you take any kind of text and do any kind of search for it. And you say re.search, and at the beginning you give it the regular expression code. Now this particular one is looking for 2 digits in a row, any digit. This is the symbol for wildcard digit. The second argument is the text it's supposed to look through, right? So you can do this programmatically and very quickly. Okay. So this will find every instance of 2 numbers together, like so. And it'll tell us where it found it between 1 and 3, kind of like Regex 101 did. And it'll tell us exactly what it matched. Okay. You can ask it, here's another bit of text. You can ask it for everything that's not a digit. That's what the /d means. Okay. And it'll give you, and you can ask it for the group rather. So this will tell you everything that isn't a number. Okay, you can give it something like a phone number. Okay, and you can ask it to search for really specific patterns of things. And you can't do this in any of the string methods, right? It doesn't have wildcards. So this particular expression here is looking for 3 wildcard digits in the beginning between parentheses, right? And then it's looking for another 3 between parentheses, and then another 4 between parentheses. And what this will do is it'll find all of the groups that match these patterns and report them out to you. Okay. If your phone number came in this form, you could create a search pattern that would take 3 digits and a dash, and then 3 digits and a dash, and then 4 digits. And that would look like a phone number in the United States. Okay. And what this did is it created a group of output for each of the things in parentheses. Okay, so if we asked it for output group 1, it would give us the area code 415. And the second group gives us the phone number, like so. Okay. If you have something like this, well, what you can do is you can pull, you can tell it, well, we want the parentheses to come out too. So you can put in escape characters. Okay. Let's see, what else can you do? You can extract the numbers. So let's say that you had this in your user input, it's a piece of crap. All you really want is numbers out of it. Well, you can use the regular expression library to find everything that's between that's a digit, right? Like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, where there's between 1 and 6 of them in a row. All right, and it'll pull those out and report them to you. Okay, you can pull out anything that isn't a digit. That's what this /d code means. Okay. You can replace, so what this one does is it takes any non-digit number and puts a dot in instead. Okay, so this is our string. We said, okay, so we want you to substitute. So it's got a replace method, right? So we're going to substitute anything that is not a digit with a dot. So it's got real similar syntax to the string replace method, but with the wildcard option. And here's our result. Or if your website was collecting phone numbers or credit card numbers or anything sensitive, well, you might not want to have numbers hanging around. You might not want them in your database. God knows who's going to hack your system. So you might want to just acknowledge you have a phone number, but replace all the numbers. Okay, and you could do that with a substitution operation like this. Okay, now the crosswalk between what Python does and what the regular expressions do that you can test here is exactly 1-to-1. So you can practice coming up with a regular expression using all these codes. Okay, all these guys. We just saw a couple of them. We saw the any digit, and we saw anything but a digit. And these are the codes. And they'll work the same in Regex 101 as they will in your program. So you can go ahead and take samples from whatever garbage users are throwing into your websites, and you could process them with straight up Python if it's straightforward. But if you want to do anything more complicated, you've got many more choices using regular expressions. And in this application, you've got the process to test out a whole bunch of stuff before you have to do an endlessly iterative thing in a Jupyter notebook, seeing how well you can make it work piecewise. And as you're doing that, this will tell you how you screwed it up, because I mean they're really hard to work with, and you probably won't get it right the first time, or the second time, or the third time, and you're going to have to play with it quite a bit. And this gives you immediate feedback on that. All right. So let's see, what else can we do in 5 minutes? Yeah, you can, if you're working, if you get a little more advanced and you start working with things like pandas, which is a Python application built on numerical Python or NumPy, which is really super popular. You can use things like contains on your objects. Okay, and this gets the string methods and a couple more. So pandas adds contains into it, and you can use these regular expressions to modify your data sets. and I don't want to elaborate, but if you have data into one of these more elaborate structures, you can apply a change element-wise to them. Okay, and what this one does is it returns the results of a regular expression and applies them to a complicated data structure. So I don't want to belabor here too much, but these regular expressions have a lot of applications into the kind of data sciencey things and the kind of natural language processing and a lot of the analytical things you guys may be doing with Python in the future. So this is a pitch to consider making them part of your repertoire as you move forward. Okay, so I'll just leave you with this. Regex 101 will give you a far better tutorial on the topic and far more interactive than I possibly could, and I highly recommend it. Okay, so we've got about 2 minutes left. Does anybody have questions on what we've covered or anything else? Oh, come on, really? Okay. Well, I hope at least some of you are awake, and I've enjoyed having you with me tonight, and thanks again for the honor of your time. I do look forward to seeing you next time, which is, I think, Saturday. Yeah. So if any of you are going to work the weekend, I'll be here with you.
Thank you.
Thank you, Pat.
much.
Thanks a lot.